Welcome to Applied Security Engineering channel. Today we are continue our theme on CSSLP Domain 1. We will cover the design part of it today. I'm sharing a presentation which we discussed in our last session as well. For those who missed the previous one, you can go to playlist and you can find a Domain 1 session in which we covered the core concepts of the application security, confidentiality, integrity, availability, authentication, authorization, and accountability. So today's topic is the design, in which cover all the design related concepts. Those concepts will be discussed in detail in domain 3 as well. So today we will cover like a broader perspective what each concept is. So the first one is least privilege. So least privilege is a concept where you're giving a process or a person an access like to the minimum level they need it, uh, and you're not giving any access outside the requirement. For example, developer only needs a read-only access to the production log. Similarly, they will publish the code via control CI/CD pipeline. Another one is uh, there will be no edits on the production database directly. So these are the least privileges you can give to the application or a developer to perform this specific task in a specific time. It is one of the major concern in when you go in a practical life. Sometimes developers or even the security person ask for the command line as an administrative access. They get an access to perform one specific task, but then there is no accountability, like whoever access privilege, and then that caused like a lot of other issues as well. So it is very important to give only user an access which they need it. Separation of duties, as you can see from its name, it's actually one single task can be dependent upon two or more conditions that needs to be met before that task has been completed. As you can see from the example, in an application security, a developer writes the code, security tool or reviewer approves it. If there is no any critical or high vulnerabilities depending on your policy, you allow them to move forward, and then the CI/CD pipeline deploys it. This way, developer cannot write code, approve it, deploy it all by themselves. So there is each process or each person has its own kind of like a specific responsibility to perform in it. Why is it important? The separation of duties. This prevent fraud. Just taking an example, if developer is the one who write the code, approve it, and deploy it, there is a chance they can publish the code without anyone's approval, and then that cause an issue as well. That again, that is another thing which is like stop insider threats. If you write the code, if you approve it yourself, there is a chance you can write a code which can allow an outsider an access. So that's where there's insider threats comes in. And obviously, you want to catch the mistakes earlier on in the development and then enforce the accountability on it as well. That's when I see there, I have a big screen over here where I have the presentation. So that's where I look for, just to move the screens. Again, defense in depth, a security principle where you have the multiple layers of the security to prevent any attack. If we take an example from the real life world, like when you go to the airport, there are different checks. Like first you have to show your ticket, then you have to show your identity, then you go for the baggage scan, body scanner, boarding gate check. So these are all like the an example of defense in depth. So that make sure like when the person boards the plane is the right person, and then there is no security threat or the security issue in that one. So same applies in an application or in IT world as well. Like you have just taking an example, like you have an online banking application. So what sort of controls you can implement or implemented, network security, firewall, and web can be implemented at network layer. Then you have an authentication, MFA, strong passwords, authorization, least privilege concept, which we just discussed, comes in play here, so that the processor or person giving only the access which they need it. Um, Secure coding practices, SAST and DAS scanning, you are doing it, and then monitoring, logging, and alerting. So these are all the layers you can add it in your application to make it more secure. That will that will reduce the impact of a threat, or like that makes the threat a little bit difficult, when you have all these things in place. And then there is no single control. For example, if the firewall fails, it's not like there's no firewall and then the user comes in, or if the password, if user password compromised, then the user logged in. Even if the password is compromised, the person who is trying to log in have to bypass the MFA as well. Once they, just taking an example, like if by somehow they're able to log in, they have a very limited access to a damage. So that's why we implement like multiple controls, so that we can control the damage. Fail secure, again, like a security principle, like to maintain the confidentiality, integrity, and availability by defaulting to a secure state. In the context of software security, like fail secure is commonly used interchangeably with fail safe. When in an application, like just taking an example over here, for example, like in an API authentication service is down, what will happen? System rejects all the request, no fallback to allow access. That is, you can say like secure by default and not open if broken. There is a possibility, if you have a bad design, or like the this principle is not implemented during the development, it is possible when the system fails, it allows access everyone. That can cause an issue as well. And then like looking into the secure state, like access denied by default, sensitive data not exposed, critical actions are blocked, system can recover safely. So these are all the steps which falls under the fail secure. And then if you look into the failure behavior, you deny access, grant access on a failure, no. Hide sensitive errors, yes. Expose stack traces, no. Because these are all the stack traces, like, are very important. Sometimes when application fails, it shows like a .NET error page, or it might throw some exception on the user screen. From there, an attacker can get a lot of useful information, which they can use it to attack the application. Economy of mechanism, which we call it like keep it simple. You don't need to overcomplicate things when you're developing a software. Just taking an example in a real life, there are two types of log. Like you have a paddock logs, and then you have a smart logs as well. If you look into the traditional ones, there are very few moving parts in it. You just need a key to open the log. Whereas if you look at the smart logs, you have an app. That app is connected with the Wi-Fi, and then there is a firmware, an API. So there are lot of like layers in it, and if any of each of these layers compromised, that can be a problem. That can break the log itself. So when we are designing an application, we always try to keep it simple, so that there is a um, less chances of breaking things. You see, like one of the points which I have right over here, reduce attack surface. So that is like kind of a very important principle when you're designing, to reduce your attack surface as much as you can. Like there will be a less moving part, and then like obviously like easier to review and test, fewer misconfiguration, faster incident response, easier maintenance as well. Whereas if you make it like a complex one, then there are multiple layers of controls you have to add, and then on top of that you have to make it like secure as well. Complexity, it's a very nice word. Complexity is the enemy of a security. So whenever you're designing an application, um, always remember this concept. Keep it very simple, as low as you can do. Just one slide. uh, Next one is the complete mediation. That is again like a security principle that ensures like every single request is checked for authorization, or for authorization, to make sure like the object or a person who's trying to do that specific task have the rights to do this thing. Let's take an example. Like user logged in, and then there is a form which user can fill in and submit. It will, just take an example, it might be an edit form or updating something. So when they submit and it goes to the server to update the database, you have to make sure like double check like the request is coming from the logged in user. Does this user have a right to update this request or not? So that is the thing you have to verify each step, to make sure you are authenticating the users while performing that action. um, just taking a real life example, entering a secure office building, which I'm sure like most of you, when you go to the office, you have to present that card or biometrics. So permissions are checked at each time. And if you are in the insurance or in a finance industry, like the doors are locked on like in each kind of like department. So whenever you go out, you have to tap your card and then you can go out. Or if you're working in NHS, you're, for example, like in a health department. So these are like kind of permissions you have to make sure like the person who is entering in this building or in this department have the rights to enter it as well. Sometimes, for example, like you have a server room, and then there is no need for the um, finance person to go there. So if they tap their card to log to enter into the room, that is like a red flag. You should not allow them. And then the same principle applies in terms of an application as well. An API that return customer data, for example, um, without like the complete mediation, user logs in once, all feature requests trusted, role changes ignored. So these are like kind of a red flags when you authorize the user. Verify authorization on every request. It's very important. Open design principle. It's an interesting one. Um, so basically, you can the open design security principle states that the implementation details of the design should be independent of the design itself. Like which can be an open one. The design can be an open, but the implementation of that design can be a secret. Unlike in a case of a security by obscurity, wherein the security of the software is dependent upon the obscuring of the design itself. So what we are trying to say over here is, the design can be on open, but the secret keys and credentials, those are like kind of things which you need to secure it. Let's take another example like the same which we discussed earlier on. Everyone knows like how the padlocks works. Security comes from the key. It's not from the padlock itself. Like it's the same padlock. You just need a key to open it. Same concept applies in an application as well. So if you are implementing encryption, or if you're implementing hashing and or all those things, so you should use the industry standards instead of developing your own custom one. Because if you develop something custom, there is a high chances that can be broken. Whereas if you're using, for example, like RSA or ES or like whatever you're using it, and then you keep the secrets, the keys and passwords as secret, that's all you need. So that's where with the open design principle comes. um, you don't need to reinvent the wheel. Use the designs which are already available, and then just keep your keys secure. Uh, let's come to the least common mechanism. What this really means, actually, so that means, like you don't share the same logic or function or resources, um, especially when user have different roles or privileges. Separate mechanism reduce the cross impact and abuse. So just taking a real life example, for example, like there is a one printer in an office. Executives print some sensitive data, whereas the general staff uses the same printer to print their routine work. Executives send the confidential document for a printing. At the same time, the general staff print something. They come to the printer and they can see that document. Um, so that's where, like you cannot use the same printer for both executive and general staff. You need to separate it. And then if we come to the example, like application example, let's have a look like the calculate bonus. That is a one method which calculate both exam bonus and non-exam bonus. There is a highly likely chance like there will be an issue, or like if there is any bug comes up in this method, and then the non-exempt one can be an exempted and exempt one can be non-exempted. So in terms of complete mediation, sorry, just give me 1 second. I just pressed twice. One more. Okay. In terms of the least common mechanism, what you need is, you need to separate out these two functions. The first function is will be like calculate exam bonus, and then the second one is calculate non-exam bonus. In that way, you are 100% sure they both are enforce their own rules and access check. So that's, um, that's where you don't mix up the logics of the both functions in a one function. So that's where this least common mechanism security concept comes in. Okay, psychological acceptability is kind of like a very major and important method in applications and in application security as well. You don't need to overcomplicate things, as I explained previously, to keep it simple. You don't need to make it harder for the users. Eventually, it's the end user who will be using your application. So if you make things very complicated, it's highly likely chance that your application can be compromised. Again, like let's take an example of a real life, car seat belt. It's very easy, it's very easy to use. Automatically reminds you, like in all in new cars, the beep start if you don't wear your seat belt. That beep thing comes in. Simple to use. That's it. Um, Whereas if they make it complicated, then it's harder for people to use that seat belt. So the same concept come up in the application world as well. Just taking an example, like if an application asks user to change their password every week, just imagine what's going to happen. Like who can change their password every week? But then what going to happen is, like users start writing their passwords with sticky notes on their laptops or iPads or whatever they're using, or on their desk itself. And that's where you can get compromised. Or these kind of a features, if you make it, just taking another example, user logged in into your own application, you authorized it, you authenticated it, you authorize it, they perform a task. When they perform the second task, you ask them to again log in with the same MFA and a password. That make things very complicated for the user. Like that's where the concept of a single sign-on comes in. You logged in into one application. Obviously, like at the back end, you need to authorize every request to make sure like this user have a right to perform this thing, but it's not something you ask the user to do it again and again. So that's where this concept comes in. Try to make it application as user friendly as you can without compromising the security. Okay, that is very interesting. Security principle that reminds us the entire system is only as strong as its weakest link. um, yeah, that's basically it is. A single weak point becomes the target, and that's what the attacker is looking for as well. Just taking an example of a real world, You have a house, you lock the door, you have a camera system, you have an alarm system, everything in place, but you left the window open, I mean, the person can comes in and like do whatever they want. That is what actually in application world as well. Um, Application have like a strong encryption, MFA, secure coding practices, whatever, like weak admin password, or unpatched dependency. Um, it's kind of like a real problem for the legacy applications. Over the years, I worked in different industries, and I see this kind of like a big problem. I was working in one organization, and we had a one app system which is using the deprecated version of .NET, and there are a lot of vulnerabilities in it, and and application is still relying on it. So whatever the compensatory control we apply on it, these are just like kind of um, makeshift arrangements, like because the core system itself is vulnerable. So if and when the systems get deprecated, like there all the vulnerabilities are available online. Anyone can go into and have a look the vulnerabilities and exploit that system if the new system is using that framework or a um, so that's where like this thing comes. It's a weakest link, regardless of all the controls. If your base system is like deprecated, then you cannot do anything. You can add compensatory control, but it's very difficult to make it secure that system. Leveraging existing components, another concept. Like um, as a security principle, like what, or as the AppSec engineer or in AppSec world, we promote like using the safe and efficient software development by using trusted and well tested components. Again, like as I mentioned before, like if you are adding an if you're using an hashing, instead of working out your own hashing algorithm and all that stuff, just use the component which is already available. Same with the encryption, like just use the TLS for encryption, and then use the OAuth or OpenID Connect. These are all well tested components available. So it's better to use those as compared to developing your own one. um, Again, like when you use in a real life example, when you install a lock in your house, you always use the tested. You look into the reviews, you look into the security of that lock, and then you installed it. You never thought about like what if I build my own lock system. That's not going to happen. Like that does not make your house secure. So you rely on the well tested components or the locks. The same example applies in the application security as well. Okay, I will stop here. Actually, I will stop here. This risk management is its own kind of like a topic. I will cover up in my next slide. So, yep, thanks for joining, guys. If you like this content, please subscribe to my channel and add your comments. If you have any question or if you want me to further explain anything, I'm happy to do that one. So the next video will be on the risk, and after that I will be covering up some domain 1 questions, and then we can go into the domain 2. Thank you.